Oh, hi, welcome back to the channel. This is Structural Analysis Made Fun and Easy. So this is the continuation of the problem, the deflection problem from the Analysis of Structures Chapter 3. So this is, we've got to calculate, this is a quick, this is calculation of the section properties for the example problem, but quick example of how to calculate the area of a circular hollow section. So we got, so it says in the problem that the members are all made of circular section, outside diameter 50 with wall thickness of 3. So that means that the inside diameter is 50 minus 3 minus 3. So that's 50 minus 6 is 44. So the area of a circle is pi r squared equals pi d over 2 squared equals pi d squared over 4. And the inside diameter is, I've called that D1, and the outside diameter I've called capital D1. So, sorry, my drawing's not very good. The area of the section equals area of outside diameter minus area of inside diameter. Therefore, the area of the section is pi 50 squared over 4 minus pi 44 squared over 4. 196.50 minus 1520.5 equals 443.03 millimeters. That looks right, doesn't it? 43. Oh no, hold on. That's not quite right. But that's 443 is right. So, the calculation of delta deflection. Oh yeah. So in the table that he did in the example, I didn't follow exactly how he got the deflection, so I'm gonna do that myself. The calculation of delta area, the calculation of delta, aka deflection extension. So that's like the extension or the contraction of the bars, depending if it's in contraction or extension. It is not stated in the book, but I contend the formula for the deflection is given by, so E, Young's modulus, equals stress over strain, sigma over stress over strain, so that sigma stress equals force per area equals N over A. So that's a little diagram of it. N, so the force is N, and the area of the section we just calculated was 443 millimeters squared. The E strain equals extension divided by length equals extension of a member divided by the length of a member. E equals force per area. Therefore, Young's modulus is force per area divided by extension over length. So you just turn that upside down. So it's times L over E rather than divided by E over L. And therefore, E, extension, delta, is force times length divided by area times Young's modulus, or NL divided by AA, where E equals Young's modulus, and in this question it says E equals 200 giganewtons per meter squared, I think. So that's the formula, NL over AA. That gives you the extension. We've got an example member. Let's start with the example that had example member AB. N equals minus 20 kilonewtons compression. L equals 3,000 millimeter long. A equals 443 millimeters squared, and E should equal 200 newtons per millimeter squared. Therefore, delta equals NL divided by AE equals minus 20,000 times 3,000 divided by 443 times 200,000 equals 0.677 millimeters. So in the next video, I had to do a spreadsheet like he did with all the extensions to get the right answer. So that's what I've done. And then add up all the extensions and put them into one piece. The total, well, I'll show you in the next video as well, but that's how you get it. Basically, what I'm trying to say is delta equals NL over AE. And then the units, it's just a question of checking the units. So it should be, as long as you've got the units right, you can do unit checks. So N should be in newtons, L should be in millimeters, A should be in millimeters squared, and E should be in newtons per millimeter squared. Right. So, and then just a quick check of how he got. So N1 in the example, N1 was the vertical deflection, delta 1V, and N2 gives you the horizontal delta 2, and the resultant deflection is just like the triangle. So you got the horizontal component, the vertical component, and then the resultant is the diagonal. So delta resultant equals delta 1V squared plus delta 2H squared square root of that. So that's how you get the resultant deflection. Oh, the angle, obviously. If in some of the later problems he's talking about angles, so obviously you've got, let's say alpha equals tan alpha. I did it this way around. Tan alpha would equal horizontal deflection divided by vertical deflection, or you could do it the other way. Tan alpha 1 equals vertical. If you took it this way, tan alpha 1 would be vertical divided by horizontal. So you arc tan that and you get the angles. So that would all be fairly straightforward. So hopefully you found this video useful. Sorry about presentation, I need to clear up a little bit, but just how you, the most important thing from this video was NL the deflection equals the NL over AE. Just remember that NL over AE, and that's how we do the calculations in the table. So see you in the next video, which will be the last part of this solution of this problem. And then hopefully you like the video. Please like the video, subscribe to the channel so I can make some more videos. Thanks. See you in the next video. Thanks.